by looking at what I've shared with you. So we're going to learn about something called diatomics. Let me write that out so you can see how that's spelled. Well, if my pen will work. Okay, so diatomics. Oh my goodness. This tablet is not cooperating. Let's try that again. Yeah. Hopefully the board will catch up to my handwriting here. Okay, so diatomics means di, two atoms. So when an element is all by itself in a chemical formula, meaning it has nobody to bond with, it either is all by itself or it's a Brinkelhoff. There are only 7 Brinkelhoffs. Brinkelhoffs are diatomic, same thing. Brinkelhoff is the trick. So we can remember what the 7 are by circling the 7th element, nitrogen, and making a 7, right? So that's one trick to remember, and then hydrogen's my other one. Okay, so I can use the 7 method, right? Let me turn off my phone there. I can use the 7 to make a Brinkelhoff, or I can think about the term Brinkelhoff. I keep saying it, and I kind of gave away the end of the thing here, but that's okay. So the other option I have is I can do Brinkelhoff. So Brinkelhoff is Br, I, N, Cl, chlorine, H, and O, and then F. So Brinkelhoff, look at that. If I take my 7th element and I make a 7, and I include hydrogen, Brinkelhoff are those elements. There is Br, I, N, Cl, H, O, and F. So Brinkelhoff and diatomic are the same. You have to know the 7 Brinkelhoffs. You have to know the 7 diatomics. I could use that word interchangeably, Brinkelhoff or diatomic. So I would jot down Brinkelhoff somewhere. I would actually put it on your periodic table if I was you, because then it's there for you to use. Okay, you need to know about the 7 diatomics, meaning when they're all by themselves, and we're going to practice this, they have to exist as a 2. So if I were to see bromine in something, bromine would have to be Br2. If I see chlorine, it's going to be Cl2. If I see just the word hydrogen, it's H2. If I would see just the word cobalt, it would just be Co, because it's not part of those 7. If I would just see the word magnesium, right, without any partners, it's just going to be Mg, not Mg2. So the Brinkelhoffs are diatomics. That means they just can't be by themselves. They just can't. Cobalt can be by itself. Magnesium can be by itself. Those 7 have to have somebody with them at all times. Okay. So, any questions about Brinkelhoffs before we go on to the next piece? Hopefully you wrote those 7 down. And I'll be saying Brinkelhoff enough that it'll start to stick in your own heads. So there's my little sketch of the 7, right? Those are the 7 diatomics. Okay, so what we're going to do is we're going to, on page 12, I'd like you to number your paper 1 through 10 and leave some space in between 1 through 10. Number your paper 1 through 10, leaving some space in 1 through 10. All right, and I'm going to do these first 4 with you, and then you're going to try some on your own. So if this was let me kind of show you what's coming, so that will make a little more sense. So do you see on the screen what we're going to do? Is we're going to have a chemical equation that we're going to have in words and have to write a balanced chemical equation like we've already learned. So we're combining 2 sets of skills. Okay, so that's what we're getting to. So we're going to start by saying, okay, I'm reading a balanced equation. I just see the word iron. So I need to say, okay, it's by itself. So it's either going to be just Fe or Fe2. And only 7 of them get to have a 2. And iron is not one of them. So iron would just be Fe in a balanced chemical equation. Bromine is Br. It's by itself. It doesn't have a partner like these have partners, right? 3 and 4 have a partner. Bromine does not. So bromine's by itself, so it's either going to be Brinkelhoff, yes or no. And bromine is part of Brinkelhoff, so I wouldn't leave it as Br. It has to be written as Br2 in a balanced chemical equation because it is one of the 7 diatomics. Okay? We'll practice this a lot as we go through this today. Questions about 1 or 2? Okay, so 3, we're just going to practice naming and writing again like we did last unit. So remember that we would do these steps. So Fe 3 plus and SO4 2 minus, right? And then I would do parentheses. I don't expect that everyone still needs to do this. Some of you still need to, and some of you still need to once in a while. Crisscross. We're going to mostly see metals when we do this unit, but not always, but mostly things ionics that start with a metal. Nothing to reduce, nothing to rewrite. So you can either go through the steps or you can just crisscross reduce, whatever you're good at and whatever you're comfortable with. If you are struggling with this skill, you need to reach out ASAP so we can practice together. Questions about 3? Strontium would be Sr2+. Now there's no Roman numeral, so remember we have to look it up on the ion sheet to see what charge it forms. Bromide is Br1-, and then if we crisscross reduce, we end up getting SrBr2. Now this 2 is not because it's diatomic. This 2 is because it's crisscross reduce, right? Yes, bromine is one of the 7, the Brinkelhoffs, but it isn't Br2 necessarily unless it's by itself. It's 2 here because it has a partner and it crisscross reduce, right? Questions about 1 through 4? Okay. Please try 5 through 10 on your paper. I'm going to give you 5 minutes. Okay, so the first one would be going through those steps. So this is going to be a +4 and a -1. Pardon me, so it would be Pb, Bro3, 4. Okay, and then the next one is going to be Mg is a +2, phosphate's a -3. So Mg3, parentheses, PO4, parentheses 2. Fluorine is by itself. Fluorine is by itself, so I have to think about Brinkelhoff, yes or no, and that would be a yes. So it's not F, it has to be F2. Carbon tetrachloride would be CBr4. So we're using prefixes. It starts with a nonmetal. Excuse me. Chromium. Chromium is by itself, so I'm thinking about Brinkelhoff, yes or no, and that's a no, so it's just Cr. Disulfur pentoxide is S2O5. Okay, di, 2 sulfurs, pent, 5 oxygens. Questions about 5 through 10. If this is still a struggle, please reach out and let's work one-on-one during office hours, or we can schedule something else and make sure you're getting solid on this because you need this skill to keep continuing this unit. All right. No questions? Then we're going to go on to back to page 11 and start writing and balancing. Okay, so here we have zinc plus lead nitrate yields, blah, 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 right? So if you see the word plus and or a plus sign, that tells you do plus. So here we have zinc, which is going to be Zn. Okay, and now it's by itself, so I have to think about Brinkelhoff, yes or no. Well, zinc's not Brinkelhoff, so it just stays as zinc. It's happy and content being by itself. Okay, then we have a lead, which is a +2, and nitrate is -1. I'm not going to show the 5 steps. I expect you're close to being there on your own. So it's going to be Pb, parentheses, NO3, parentheses 2, crisscrossed reduced. Yields tells us to draw an arrow. You'll see words like yields, makes, produces, forms. Okay. Then we have zinc, which is a +2, and nitrate is a -1. So it's going to be Zn, parentheses, NO3, parentheses 2, crisscrossed reduced. Plus lead. Lead's a word by itself. I have to consider Brinkelhoff if I have something all by itself, which I do in this case of lead. And lead is not a Brinkelhoff. So I will not give it a 2. I have to keep it a 1 if it's not one of my 7. So now you're going to take a moment to either tell me it's balanced or balance it already. So either balance. All right, number 2, we've got aluminum bromide. So we know that this is going to be a +3 and a -1. Why? I looked them up. I'm going to crisscross reduce this. Now, I want to point out something very important here. Aluminum is with bromine. Yes, bromine, Br, is one of the 7 diatomics. But remember, I only apply the diatomic rule, putting a 2 with it, if it's all by itself. And bromine is not all by itself. It has a partner, so it doesn't need the 2. It needs the crisscross reduce. Okay? Chlorine by itself. So I'm doing Cl. I pause and say, is it a Brinkelhoff? Yes or no? Yes. So it has to be Cl2. Yields tells me to draw an arrow. Aluminum chloride is +3 and -1. So I'm going to crisscross reduce that. And again, Chloride, yes, it's a Brinkelhoff, but it doesn't get Brinkelhoff rules if it's not by itself. It gets the other rules if it's not by itself. So either crisscross reduced, acid rules, or prefixes. Now bromine is by itself. So that's going to be Br, and then I have to consider Brinkelhoff yes or no, and it's a yes, so it's going to be Br subscript 2. Okay. Questions about what I've written? Okay, take a moment to balance it, please. Okay, so let's go through this one. First thing I would recognize is I have 3 and 2 for bromine, so I'm going to get them both to 6. So I put a 2 on the left in front of AlBr3, which gets me 6 bromines. I got to put a 3 in front of Br on the other side to get 6 bromines. So my bromines are good, but when I put my 2 on the left in front of AlBr3, I got 2 aluminum, so I got to put a 2 in front of AlCl3 on the right, which makes my aluminums good, but now I have 6 chlorines, so I got to put a 3 in front of Cl2 to get 6 chlorines. Questions about 2? Okay, let's look at number 3. So we know Na is a +1 and phosphate's a -3. So we're going to crisscross reduce that to be Na3PO4 plus calcium is a +2, chloride's a -1. A -1. Sorry, I thought I was doing that wrong. CaCl2 for that one. Crisscross reduce. Yields. Calcium is a +2, phosphate's a -3. So Ca3 parentheses PO4 parentheses 2 plus sodium is a +1, chlorine is a -1. NaCl would be my chemical there. So all of these were metals and all of these were crisscross reduced. No Brinkelhoffs to worry about because nobody's alone. Questions about anything I've written before I have you balance? Okay, please take a few seconds to balance. We'll go over it in just a few minutes. Well, minutes, in just about a minute. Okay, so perhaps you'd look at the phosphates first, is what I would do. And I'd see I have 1 phosphate on the left and 2 on the right. So I'm gonna put a 2 in front of sodium, phosphate, which gets me my phosphates balanced, but now I have 6 sodiums. So I'm gonna put a 6 in front of sodium on the right, which gives me 6 sodiums, but also gives me 6 chlorines. So I'm gonna put a 3 on front on the other side where chlorine is, which gives me 6 chlorines, but 3 calciums, but I have 3 calciums on the right, so it's balanced as a 2-3-1-6. 2-3-1-6. Questions about number 3? Okay, on to number 4. We have potassium, which is a +1, and chlorate, which is a -1. So when they're the same numbers, remember we just squish them together. But chlorate is ClO3, different than chloride. Chlorate is ClO3. When heated, it's just descriptive. We don't need it for this unit. Okay, so that just means an arrow because we get to yields. Potassium is a +1, chlorine is a -1. So we're going to do KCl, crisscross reduce, plus oxygen gas. Gas is descriptive. We don't need it. That is something we will need eventually, but not today. The state of matter, like gas, solid, liquid, whatnot. But for today, we don't need it. So it's going to be O2. Why O2? Because oxygen is by itself. And when something is by itself, I have to consider Brinkelhoff yes or no. And it's a yes. It's one of the 7. Chlorine didn't get a 2 over here because it wasn't by itself. I can only apply Brinkelhoff if they're lonely and by themselves. And then I have to consider yes or no. Okay, take a moment to balance it. Okay, guys, let's go through balancing this. So I see K and Cl look great. Oxygen is 3-2. I got to get them both to a 6. So on the left, I'm going to put a 2 in front of KClO3, which gets me 6 oxygens. I'm going to put a 3 in front of oxygen on the right, which gets me 6 oxygens. But when I put the 2 in front of KClO3 on the left, it gave me 2 Ks and 2 Cls. So I got to put a 2 in front of KCl to get that balanced. Questions about number 4? Okay, number 5, I want to bring it down a little bit so I can write stuff on top. Okay, so for number 5, we have aluminum by itself. Okay, So I got to think about Brinkelhoff, and it's a no. So it just should be Al. Remember, Brinkelhoff, when they're by themselves, you either get to apply Brinkelhoff with a 2 or you get to apply nothing, just the element name. So this would not be Al3. It's just Al. Now, we have a hydroic acid, so that goes to ide. So we're looking up chloride, and we see that chloride is a 1-, so HCl. To be honest with you, if you memorize hydrochloric acid's formula, you will save yourself a lot of trouble going forward because we use it a lot. There's 3 acids, hydrochloric, sulfuric, and nitric. Those are the most common 3 acids that you hear about in chemistry, in my opinion, when it comes to non-organic chemistry. So AlHCl. Yields tells me to draw an arrow. I have aluminum and chloride, so that's going to be crisscross reduce AlCl3. Plus, we don't care about the term gas right now, but we do care about hydrogen. Hydrogen is an element name by itself, so I have to consider Brinkelhoff yes or no, and it's a yes. So it has to be H2. Where aluminum was by itself, but it was not a Brinkelhoffer, so it has to be just an Al. All right, take about, a few moments to balance that. All right, let's go through balancing this one. I see that I have 1 Al, 1 Al, 3 Cls, and 1 Cl, so I'm going to put a 3 here, which gets me 3 Cls and 3 H's, but now I have 3 H's to 2 H's. This is one of those circumstances when doing H last doesn't help, but it's so rare that I would stick with the rules I taught you. So we're going to have to fix H. 3 and 2 is what we got, but we're going to have to get them to 6. So instead of putting a 3 here, I'm going to put a 6 here because I need 6 H's. So now my H's look good when I put the 3 in front of H2, but now I have 6 H's and 6 Cl's. So I got to fix that. So I'm going to put a 2 here to get 6 Cl's. So now I have 6 Cl's, but now I also have 2 aluminums. So to fix my aluminums, I'm going to put a 2 over here. And remember, it doesn't matter if we change coefficients, as long as when we get done, it's balanced in the simplest ratio of numbers. So 2, 6, 2, 3 is the simplest ratios. I have seen some of you put into the quiz checks something in this one, for instance, like 4, 12, 4, 6. While 4, 12, 4, 6 balances it, the rules are that you have to have the simplest whole number ratios when balancing. So always quickly look at your coefficients and make sure they aren't doubled. That happens from time to time, and you don't want them doubled. Questions about number 5. Okay, on to number 6. So we're going to do calcium hydroxide. Let me bring that down some so I can write stuff above it. Okay, so calcium is a +2. Hydroxide is a -1, so we're going to crisscross reduce there. Then I have an ic acid. And remember that this, going back to calcium hydroxide, you have to put parentheses around hydroxide because it's poly. I have an ic acid, so it goes to 8. And phosphate is PO4, 3-. So I need H3 PO4 for my phosphoric acid. Yields tells me to draw an arrow. Excuse me, I have a calcium, which is +2, and phosphate's -3, so I'm going to crisscross reduce that. And then I have water. Now I'm going to write water as HOH this time. Why? Because I have an OH on the other side. It is often helpful if you have an OH on one side and water on the other that you write water as HOH. It helps. Okay, take a moment to try to balance this if there's no questions about how I wrote it, and then we'll go over it in just a moment. Okay, guys. Okay, let's go through that, pardon me, together. So I'm first look at OH as a 2, so I'm going to put a 2 over here in front of hydroxide, which gives me 2 H's. But now I see that my H's are not balanced, but I'm not going to worry about the H's yet. I'm going to come back to them. You could, and that's a fine way to balance. We got 1 PO4 and 2 PO4, so I'm going to put a 2 here, which gets my PO4s balanced. Remember, I said it often helps to leave hydrogen to dead last. So we've got 2 PO4s on each side, but now I've got 6 hydrogens. So instead of putting a 2 in front, I'm going to put a 6 in front of HOH, which then gives me 6 OHs and 6 H's. I needed the 6 H's. That's awesome. But now I got to fix my 6, get 6 OHs. So to get 6 OHs on the left, I'm going to put a 3 in front of calcium hydroxide. That gives me 3 calciums, and I already had 3 calciums, so now I'm going to double check. 3 calciums, 3 calciums, 6 OHs on the left, 6 OHs on the right, 6 H's on the left, 6 H's on the right, 2 PO4s on the left, 2 PO4s on the right, and we're balanced with a 3-2-1-6. Questions about number 6? Okay, number 7. You're going to have copper, which is by itself, so we have to think about Brinkelhoff, yes or no, and this is a no, because it's not part of 7 Brinkelhoffs. Sulfuric, so remember Ic goes to 8. Sulfate is SO4 2-. So we got H2SO4. Yields tells me to draw an arrow. I got copper 2 and sulfate. Copper 2 sulfate, they're the same number, so we're going to just squish them together, plus water. Now in this case, it's not going to be helpful to write water as HOH because there's no OH on the other side. Okay? And I'm going to balance this one with you because this is the first time we've had a scenario like we're about to get into. And then sulfur dioxide, right? Dioxide, remember that's the prefix rule, so it's S, no prefix, di, 2 oxygens. Okay, let me get you a second to copy that, a couple seconds to get that copy down, and I'm going to show you how to balance this because this is a difficult one because it doesn't follow the tricks I tried to show you with the quickest way. All right, please look at the screen if you're not so you understand. So sulfate, it would normally be what we'd start with, right? But if I do that, then I'm leaving this sulfur with nobody over here to balance off of. And that happens so very rarely, but this is a case when it does. So we're going to do then individual atoms. We're going to do Cu, we're going to do S, we're going to do H, and we're going to do O. I still would suggest leaving H and O second to last and dead last, but we can't do sulfates because if I put SO4 here, then this S with the sulfur dioxide will have nobody to balance with. So I have to break it down to old school single elements. You can always balance this method, but if you do it with the polyatomics, it often makes it way faster to balance. So we got 1 copper on the left, 1 sulfur, 2 hydrogens, 4 oxygens. On the right, we have 1 copper, 2 sulfurs, 1 from sulfate, 1 from sulfur dioxide. We've got 2 hydrogens and 4 oxygens, 5 oxygens, 6, 7 oxygens. So 4 from the first piece, 1 from water, 2 from sulfur dioxide. Okay, so coppers look good. Our sulfurs are unbalanced. So first we're going to put a 2 in front of H2SO4, which gets my sulfurs to 2. Sulfurs become 2. Coppers didn't change. Hydrogens become 4. And oxygens become 8. Anybody confused by my numbers at this moment? Okay, so now copper and sulfur look good. Now we're going to do hydrogen on the right. So we need to get both of them to 4. So we're going to put a 2 right there. I didn't leave enough space. We're going to put a 2 in front of that water, which is going to give us 4 hydrogens. 2 times 2 is 4. And then let's see how many oxygens we have now. 4, 5, 6, 7, 8. And now we have 8 oxygens, and it's balanced with a 1, 2, 1, 2, 1. Questions about number 7. That was a tricky one just because we couldn't use our shortcut rules. Questions about number 7. Okay, let's look at number 8 then. Last one on this page. So we have hydrogen by itself. So we think about Brinkelhoff, yes or no. It's a yes. Plus nitrogen, but it's not by itself. It's with somebody. So we got to apply the rules. In this case, it's prefixes. Nitrogen monoxide, so 1 nitrogen, mono, 1 oxygen. Yields tells me an arrow. Water, I'm going to write it as H2O. Why? Because there's no OH on the other side, so it's not helpful to write it as H2O. Plus nitrogen's by itself. It is a Brinkelhoff, so it has to be N2. And we're going to balance it. I'm just going to go ahead and balance it with you. So we got nitrogens first is what I would suggest. We have 1 on the left, 2 on the right, so I'm going to put a 2 in front of NO to get 2 nitrogens on each side. Then I'm going to look at hydrogen. Hydrogen's 2 to 2, but oxygen is 2 to 1. So I got to fix my oxygens by putting a 2 in front of water. So now my oxygens are good, but I just messed up my hydrogens. I need 4 hydrogens on the left, so I'm going to put a 2 out in front of here. So this is balanced with a 2, 2, 2, 1. This is balanced with a 2, 2, 2, 1. Questions about this? Okay, put your name at the top of that paper because when I